zoom in here a little bit, it consists of 4 different projects, as you can see it here. This is our Azure Function, serverless function.
So, welcome to the August meetup from the .NET Community Austria, presented by .NET Devs AT. Who are we? .NET Devs are a non-profit association whose purpose is to spread the knowledge and experience about the usage of .NET technologies. What are our goals? Making it easier for new participants to find access in communities, offering existing members more choices, and promoting exchange between different communities. Where do you find us? We have a website. We're on Twitter. Of course, you're now on Twitch. And yeah, we have a YouTube channel where you'll find all our meetups recorded. And when you want to exchange with us, we have a Slack channel. So I will post now the links. Find the links. So next, everybody, thank you for joining us. And hopefully you enjoyed the talk today. Next thank you goes to our sponsors. At the moment, that's Tieto and JetBrains. So, and now, what is a short introduction today? Well, I hand over to Rainer with his topic, real-time serverless apps with .NET, Azure Functions, and SignalR. Rainer?
Yes, I'm here, and I hope you can hear me loud and clear. Can you hear me? Just give me a quick feedback so that I know that everything is okay.
So,
Raul, can you hear me? Okay, I guess you can hear me, so I will just continue speaking. If you can't hear me, if you have any technical problems, please let me know.
One moment, we have an echo. I think I mute my Skype mic.
Okay, I will wait for a second.
So now it's better. Did we have an echo on the community outside the world? Rainer, say something.
So, Raul, can I start?
Yes, it's better now. You can start.
All technical problems solved?
Yes, I think the echo gone away. So.
Well, I hope so. So let's get started. Thank you for having me. Thank you for letting me do this talk. It's a very interesting topic. I've done a similar talk a few weeks ago, completely based on JavaScript, TypeScript, and so on. And I'm very excited to be here today in this .NET Meetup to cover the same topic with a different language. So today it's all .NET, it's all C#, it's all Async and serverless, a lot of interesting topics that we have to cover today. I promised you a lot of code and a lot of code. I will just use a few slides to introduce myself, to give you some important information, and show you one conceptual slide, and then we will dive a larger sample with which I will demo all the technologies that I would like to bring together in this talk today. So with that, let's get yes. A bad echo, okay? I hope it's not from my side. Okay, I will wait until I get an okay from your side. Yes. I can tell you a joke, but I'm not that good in telling jokes. So I will just tell you a little bit about myself. It's not that important. So this one can have an echo. My name is Rainer Stropek. I'm a developer. I'm an entrepreneur. I have a small company which is called Software Architects. This company helps small, medium, and large companies to be successful in the cloud. I personally do a lot of work in Azure. Therefore, I'm an Azure MVP, a developer technology MVP, and a regional director. And if you want to get in contact with me, best is to either send me an email or contact me via Twitter. Here on this slide, you have my Twitter handle. Raul, can you tell me whether it's good? It's now good. Very good. So we have solved all the technical problems, and I guess I can continue, right? Good. Very good. Good. So As I told you, I will only show you a few slides. Most of the time, we will develop and look at some code samples and code snippets. And I have put my code sample together with some important documentation about SignalR and so on behind this AKAMS link. Christian Schwentner, the dev PMM from Microsoft Austria, was so nice to create this short link for me. Please go on and visit this link, and there you will find a link to my slides, to my samples. You can download everything. Everything is on GitHub. Use it just as you want. Everything is open source. Copy it, use it, redistribute it just as you want. I would also like to point out that Microsoft Austria sponsors a lot of very interesting free Azure trainings. So if you are new to Azure and you want to learn new Azure things, make sure to check out this AKAMS link. And if you have any questions, I'm pretty sure that Christian Schwentner from Microsoft Austria will be happy to answer any questions. Okay. That was the introduction part. So now let's go into the core topic of this talk. What is the problem that I want to present a solution for today? The problem is, how can we handle long-running async processing of business transactions which run in the backend, maybe in a microservice system? Let me show you a quick drawing here. Imagine the following situation. You have a, for instance, single page app, could be an Angular app. In our case today, it's a Blazor app, any kind of mobile app or web app that wants to do something. Then we have a backend server. And if we do just an HTTP request and then do all the kind of backend processing which is necessary to fulfill, for instance, a complex order, it takes a while. Of course, you can keep the whole HTTP request idle. That's possible. But then you have some problems if your long-running processes are taking too long, because the network infrastructure might cancel your HTTP requests. And on the other hand, the end user doesn't have a good user experience, because she has to wait for seconds and seconds, maybe minutes, until she gets feedback what has happened with a business transaction. One solution which I commonly see is to replace communication in the backend with asynchronous communication protocols, like, for instance, an Azure Service Bus, any kind of messaging infrastructure. That's possible, but then it's getting more complicated to implement the server side, the backend for front-end services here. So we need a different solution. One solution that I frequently see is polling, and we all know it's inefficient. What do I mean with that? You send an HTTP request with a business transaction, let's say the order, to the server, and there the order is processed step by step. But whenever some backend systems tell you that something, a part of the business transaction has been fulfilled, you store that, for instance, in a database, and the client is continuously polling for the current status. The client can update the user interface, which is the Blazor app, for instance. But we all know that's very inefficient, because you have to pay for the resources that handle the polling stuff. And additionally, polling isn't very fast. You have a polling interval. The faster the polling interval, the more network traffic you generate. All in all, it's not a very good solution. A better solution would be a server-to-client channel, a server-to-client communication. And here, obviously, WebSockets and the SignalR protocol come into place. Let me show you in this diagram how this will work. You have the single page app, for instance, the Blazor app, the Angular app, the React app, whatever you have. You have the server, and this server now enables the client to open a duplex communication channel, for instance, using WebSockets with on top the SignalR protocol. Whenever the backend reports back some progress in processing and asynchronously processing the business transaction, the server can actively push information back to the client. Therefore, no need for polling, and we get immediately feedback from the server if something interesting happens. So I guess these technologies, WebSocket, SignalR, and so on, they should be nice if we can implement all of these things in typical distributed microservice-oriented backends. And this is exactly what I want to show you. But I want to add another piece of technology, because implementing that with ASP.NET Core and SignalR would be rather simple. The interesting stuff that comes in is the serverless part. In this demonstration, in this today's talk, I would like to implement this middle tier here completely 100% inside of serverless Azure Functions. And that gives us a lot of problems. Why? Why do we have problems? Well, if we use SignalR and WebSockets, we know that there has to remain an open connection between our client and the server. But this is a kind of contradiction with the principle of serverless. There is no server. We don't have a server which is continuously up and running and ready for a huge number of WebSocket connection. It's simply not there. On the other hand, if we're talking about serverless, we need scalability. So we will not have a single server. We will have lots and lots of servers. And as we all know, WebSocket connection terminate on a specific server in our server farm. If we have multiple servers in the backend, all these servers have to talk to each other because one client can be connected to server A and the other client can be connected to server B. And then if A wants to talk to B, it has to do some backend communication between the servers, a lot of difficult stuff. You typically bring in some Redis cache or similar technologies to coordinate the servers. It's difficult and we don't want to do that. We want to simply focus on serverless functions and we want to delegate all the heavy stuff to Azure. And for that, Microsoft has introduced a serverless SignalR service inside of Azure. So today, we will not implement SignalR and WebSocket termination on our own, but we will use the ready-made serverless SignalR service. Our connections, our client connections, will connect to Azure SignalR. We don't have to care for the servers. We don't have to run the servers at all. Everything is done by Azure. And we, in the background, with Azure Functions, we just talk HTTP to our Azure SignalR service. And with that trick, we can make everything serverless. We don't have to do the heavy lifting coordination in the backend between the WebSocket servers and so on. And you will see the programming model is really nice. And that enables us to have the best of both worlds. We can do backend processing with asynchronous communication via service bus messaging, microservices talking to each other and so on. And at the same time, we can keep the duplex communication to the client and inform the client whenever something interesting happens. Of course, we have a lot of detailed problems that we have to solve. For instance, we have many clients and they authenticate using tokens. So if we want to send back the status of a business transaction, we have to somehow find the correct client based on the tokens that were used for authentication and all this stuff. And this is all the things that I would like to show you in the upcoming, let's say, 45 minutes. These were all the slides that I would like to show you. But as you can see, I have added some more slides here in this slide deck. These other slides are for those in the audience who are not that familiar with WebSockets, SignalR, and Azure, and so on. So take a look at these slides. If some of the technologies are rather new to you, they contain a lot of links, as you can see here. Just follow the links and you can read the details about WebSockets, SignalR, and so on. If you are new, you don't have to immediately leave this meeting. I guess you will understand many of the concepts just from the context that I show you them. But I'm sure you maybe want to know more details, and then hopefully all these slides will come in handy. So with that, let's jump right into it. Here, I have created a small sample solution in Visual Studio. It consists of, let me quickly zoom in here a little bit. It consists of 4 different projects, as you can see it here. This is our Azure function, serverless function. This is .NET Core 3.1 because .NET 5 is not yet supported for serverless functions. Here we have the data model. In our case, the data model is trivial. It's just a single order class. Of course, in your use cases, it might be more complex. Here we have some simulation of complex order processing. That's the core business logic. It doesn't do anything. I will show you the code in a second. In my case, it will just wait for a bunch of milliseconds to prove the point. But please use your imagination here. In your case, this would be communicating with the backend ERP system, doing complex database queries and things like that. This is where the heavy lifting is done. And finally, we are here in the .NET Meetup, so therefore I wanted to use C# all over the place. So I've decided to create a Blazor web client. So we use WebAssembly and the new Blazor components to implement a single page app where we trigger the orders and so on. Okay, so let's take a look at the very simple stuff. This is our order. I just leave it here on the screen for a moment. I guess you will understand everything. It consists of an order ID, a custom ID, a product, an amount, and a user ID. This is the user who placed the order, okay? Then, second one, we have the order processing. I try to keep it very, very simple, but we have to talk conceptually about the two different methods that I created. The first method here is called verify order async. This verify order async is a lightweight process. It just does the absolute necessary checkings of the order. It doesn't do any heavy lifting. We assume that verifying the order is done within a few dozen milliseconds. In our case, as you can see it here, I'm just simulating lightweight processing by waiting for 50 milliseconds. Process order async, on the other hand, does the heavy lifting. And as you can see here, I decided, of course, to do it asynchronously, and it receives an iProgress of string and reports back here in the business logic some steps that were done. We can imagine that, or we assume here, that processing takes between 10 and 20 seconds. So we don't have a really long running process here. We don't have a process that takes minutes or hours or even days to complete. This would be possible with Azure Functions too, but then we would need durable functions, and that is out of scope today. But still, you see, 2 seconds to do some availability checking, maybe complex database queries, 2 seconds to talk to the ERP system, 2 seconds to do some credit card processing, and then we are done. So again, please use your imagination. Here would be your complex business logic, and we just simulate it for the sake of this sample. So that is given. Now, what do we have on the serverless part? Currently, we have one interesting function here. This function, as you can see it here, is called receive order. So this function, receive order, is triggered by incoming HTTP requests. So we can call it at localhost 7071 API/orders. We can send a post request. We have to send in an order object, which we deserialize here. Then we do the lightweight verification. We don't know the user ID yet because I've not added authentication. We will do that in a second. We specify, we create a new order ID, and then we do the heavy lifting, do all the processing stuff inside a single HTTP request. So this keeps the HTTP request active for quite a long time. We will get rid of that, don't worry. And then we report back either OK or an internal server error. And on the client side, and then we can start working, we have a very complex HTML page. It just contains a single button, send order, and then it displays a bunch of messages. That's all. And in the backend, in the C# code, all we do is we send, as you can see it here, the order, which is just a dummy order in my case here, to our endpoint. And at the end, we just display that everything is okay. So this is what I prepared for you. No SignalR yet, no async processing yet. We will add all these things in the upcoming 45 minutes. So let me start this application so you can see that it really works. As you can see here, our Blazor server comes up. It runs on 5001. And here, our Azure function runtime runs locally. We will not deploy anything to Azure today because, if it runs locally, you have to simply trust me that it also runs in the cloud. And here you see the button. let's click on send order. And as you can see, sending, and now the HTTP request remains open. The user experience is very, very poor. Did you see? It took many, many seconds until we finally got the confirmation that the order was successfully not only sent, but completely processed. Let's do it again. Send. Now we are asking ourselves, what has happened? Is everything dead? What's the matter? And now we are relieved that everything is okay. What we want at the end of this session is, first, we want to be able to log in order to prove that we can talk to specific users. And we want to see all the different steps which happened in the async processing. And we want to push that through our serverless function. So this is our goal, and this is our starting point. And with that, we start with writing or copying in some code, because of course I have prepared the solution, and I would like to copy in the code step by step so that we can experiment a little bit with the code, and you will see how we build the solution one piece after the other. If you want to try all the things that I show you at home in the GitHub repository that I mentioned at the beginning of the talk, you will find the starter solution, with which I started here. And you will also find the ready-made solution. So you can check both. Or if you want to do it step by step, take the starter solution. If you want to just take a look at the ready-made sample, open the ready-made sample. Good. Let's start with authentication. And let's start on the client side. Let's pull in a small application service, authentication service, which I added here, as you can see it here. We will take a look at this authentication service in a second. The only thing that I have to do in order to make everything work, I have to here publish this authentication service in Dependency Injection. Now, what does this authentication service do? It's a very naive implementation of retrieving or building a JWT, a JSON Web Token. A JWT token is a token that you would get from any OpenID Connect authentication server that you might use on the web. It could be Azure Active Directory will give you a JWT access token. Could be Identity Server will give you a JWT access token. Could be Auth0, could be GitHub, could be Facebook, could be Google. I don't care. They all give you a JWT token. This talk is not about OpenID Connect. So I wanted to keep things really simple in order to focus on the interesting parts. So these few lines of code, they just create a JWT token out of thin air. So what I take is a dummy issuer, a dummy audience, a dummy secret. By the way, we can find all these settings here. So you see, really, really secure. And at the end, we build a token and return the token. Please, again, use your imagination. Here, this acquire token async method would, as I told you, use the OpenID Connect protocol to talk to, for instance, Azure Active Directory to retrieve a token. But in our case, it's just generating this token out of thin air because security, or let's make it more concrete, OpenID Connect and Azure Active Directory, they are not in scope of today's talk. So we just assume that, yeah, it simply works. Good. With that, we can start to get such a token inside of our client. Let's add a second injection here. As you can see it here, for those of you who are not that familiar with dependency injection in Blazor, this is how you do dependency injection in Blazor. This index is a razor page, as you can see it here. You probably know the thing where you have this add code here at the bottom. I personally don't like mixing HTML and C# in a single page or a single file. Therefore, I created a separate partial class here, which contains the code for our user interface. And this will then run in the client using WebAssembly. This is what Blazor is really great. So with this, we will get our authentication service inside of our UI page. And now we can add a little bit of code at the beginning, or let's put it this way. We can add two things here, a login and logout method. Let's do it this way. I will walk you through this code in a second. We don't need that one yet. We will put that in later on. And finally, we will add a small property, which I call token, as you can see it here. You can see I added, oh, we don't need that one either. We will add this code in a few moments. So in the login method, we do nothing else than acquiring the token. And in the logout method, we do nothing else than forgetting the token and clearing the messages. Finally, to make all that a little bit meaningful, we go to our send order method, which we can find down here, and we will pass in the token into our function call. So this would be similar to what you do if you do real world authentication. If you do Azure Active Directory or Identity Server or whatever, you have to acquire a token, however you do that, with some kind of flow. If you're not familiar to OpenID Connect, just believe me, you will get a token. And finally, you present this token as a bearer token when calling the web API. You ask yourself, hey, Rainer, where is SignalR? Where is async processing? It's not there yet. But this is an important thing. I wanted to make this, I wanted not to oversimplify this sample. Therefore, we add a token and user information, because later on, when we send back status information, we need to send it back to specific users, because we have hundreds or thousands of users connected to our web application. Okay? Good. This is our sending the token. With that, we can go back to the server side here in the receive order method and add a little bit of code in order to do the token checking. Well, that's simple. I've prepared that code, and I will just copy in this code here. That's it. And with that, we finally need the service which will do the token validation. And this service, I've also prepared it. Let me copy it in. It's in the server part here. I will, of course, show you the code also in a second. It's a very simple implementation, also rather naive. It's just doing, as you can see it here, with the JWT security token handler, a validation of the token. And if it's correct, it takes out the username, the subject ID, which in our case will be, for instance, John Doe, and gives back the username. So this is our authentication mechanism. So now we have completed the authentication mechanism. The only thing that I need to do is I need to publish it using dependency injection. Okay, nice. Let's do the last steps, and then we can do our second debugging session, because of course we need dependency injection here. So let's do the authentication service here, and let's assign that to a field. And now auth should be okay. And we can now get the username from the token, because now we have the user which we get from the token. Everything should be okay. Now keep in mind, we now have a serverless API which plays nicely with any kind of open API authentication server. For instance, Azure Active Directory. And we need that in order to combine that with SignalR, because whenever a SignalR connection comes in, we also need to use the same access token to authenticate the SignalR connection in order to find the right user ID and push information to the correct browser window. So that's the idea here. Good. So let's add a little bit of UI, because if we don't have anything here, we cannot do a lot of things. Let's add two buttons here. Let's call this one H2 login and logout. And here we just add two buttons. As you can see, the first one logs us in as John Doe, the second one as Jane Smith. We also add another button here which says logout. As you can see it here, nothing special. It's disabled if we don't have a token, or if we already have a token. And finally, we will display the result here with the order management only if we are logged in. So in this case, I'm just checking that a token is present, and then we display the order management, and we have the button with the send order. Okay? Nice. Let's try that before we start async processing and sending back of the SignalR messages. In order to show you that it really works, I will set a breakpoint here. This is the serverless service. This is the Azure function. And hopefully we will have a user here. Let's see. Good. Let's do a login. Okay, we are logged in. And now we send the order. And here we are. And if I hover over, you can see now we have John Doe. And this John Doe was now extracted from the JOT token. In this case, I'm just using the subject claim from the JOT token. And with this, I've proven that we now have a JOT-based authentication from our Blazor client down to our serverless function here in the ASP.NET Core part. Of course, I can let it run to the end. The bad user experience is still there. We have to wait. We question we think we are insane. And finally, we see, yes, we got our order. Everything will be sent to us. We are happy now. Good. We have done an important step. And with that, we can inhale, exhale, and start a completely new topic. Because what I want to get rid of here in the next step, I want to get rid of the process order stuff. This is the stuff that really takes a long time. So this is the stuff that I don't want to do. Let's remove that guy here. And somehow we need to start async processing by sending a message through Azure Service Bus. If you can remember what I showed you at the beginning with the slides here, this is replacing the processing from here or putting the processing to a different function, which is triggered using a service bus queue. This is what we want to do. For that, we need to change our function signature a little bit. We have to add here in the receive order, we have to add a service bus output binding. That means that we can now send messages to a topic that I have prepared for you. I created a service bus in Azure. I will not show you how to do that. You find the ARM template, the Azure Resource Manager template inside my GitHub repository. Just trust me here. I created an Azure service bus, which is completely serverless, so it fits in nicely. And with this service bus output binding here, we can now send a message instead of doing the heavy lifting directly in the receive order message. So I created a small helper function, as you can see it here. It creates a service bus message from an order by just serializing the order into JSON. Nothing special here. And now we can use this helper function in order to do that one. So now we send the order through our service bus topic by adding it to the orders topic, which is, as you can see here, a service bus connection. Yeah? Very, very simple. We just create a service bus message and add it to the so-called async collector. This is just the way how you send output messages, multiple output messages if you want, through an Azure function. And finally, we do no longer answer with OK or internal server error. We just respond with created. Created means, yes, I got your request, but it will take a while until I'm finished. But now we have a problem because the user will now not get a final confirmation that the order has successfully been processed. The user only knows, yes, the order has been received, but the user doesn't see that the order was processed. For that, we need SignalR, okay? But before we need SignalR, we need a little bit of a mechanism in order to really process the message from the service bus. So let me copy in some code. Let me remove a little bit of code here. Let me remove that one and that one. Okay, and we forget about the SignalR stuff here. Now you see, For those of you who are not that familiar with serverless programming in Azure Function, this is how you do serverless programming. The first serverless function was triggered by HTTP, and it sent a service bus message, output binding. Now, with the second function here, we just add a service bus trigger. This will be automatically triggered by our service bus message. Of course, in real world, these two functionalities don't need to live in the same Azure function. They can be in different microservices. For the sake of clarity, I added it here to the same .NET assembly, but this doesn't need to be the case. This can really be an asynchronous communication between two different serverless functions. And of course, because of the platform independence of serverless functions, one of them can be implemented in, let's say, C# and the other one can be implemented in Node or Python or Go or any other language that can somehow access service bus, and that is essentially every mainstream language that is out there. So keep in mind, this looks a little bit like being tightly coupled, but it isn't. Yeah, just for this sample, we put it in the same file, but it doesn't need to be that close. So now here, process order does a little bit of log information and it calls the process order, but then we have a big problem because here, at that point in time, we have no idea who our client is. The Blazor function got its answer here. Now, in our case, milliseconds, in real world, maybe seconds or minutes later, somebody else will asynchronously be triggered by the service bus and do the heavy lifting of order processing. And we have no way from this point in time to talk back to the client. And this is exactly where SignalR comes in. But first, let's do some debugging. So I will set the breakpoint here and we will see whether our service bus connection really works. Let's get it running. Let's see if I screwed something up. Hopefully not. Okay, log in as John Doe, send the order. We wait. Okay, let's check. It's John Doe. Let's continue, crossing fingers, and yes, here we are. Now we are conceptually in the second microservice, and this microservice does the async order processing. So the connection between our microservices in the backend worked just fine. So to set the context here, let's take a look at my slides. We now have here receiving, let's put it here. Here we receive the order. We do lightweight processing immediately. Lightweight processing means checking the order within a few milliseconds, and then we immediately return a created or accepted HTTP status message. We send a service bus message here, and this service bus message will then trigger a second microservice which does the heavy lifting, and maybe later on we can send back something here, but in our case we really want to send back something here. This is what our goal is. Okay, I hope you are still all with me and you understood what we did so far, because now it's getting really interesting. Because now we add SignalR to the game. I told you that I will not deploy anything to Azure, but of course I did because I'm using Azure here, and I can show you here in Visual Studio Code the ARM template where I created the so-called SignalR service. SignalR service is, as I told you, a serverless service which will just sit there and terminate the WebSocket connections. So you offload the heavy lifting of maintaining all the WebSocket connections to a different Azure service. It costs a few euro per month, and it can scale to thousands and thousands of connections. Here we have some security here. That's not that interesting, but the important stuff here is this one, because this is, for if you ask me, the really unique selling proposition of the SignalR service. Yes, you can use the SignalR service if you implement SignalR in the backend. That is not the case for today. We want to go all serverless. So we tell SignalR that we, in our own code, do not implement SignalR. We want to delegate the entire SignalR stuff to this serverless service. And we want to just be notified if something happens, and we want to use Azure function bindings like triggers and, for instance, output bindings and things like that to interact with this service. We don't want to see the details of WebSockets or anything like this. So this is what I deployed already for you. The programming model looks pretty interesting, and let me quickly copy in a little bit of code here, the order processing hub. This is what I would like to copy in here, the order processing hub. Those of you who are familiar with SignalR, you already know that SignalR works with the concept of hubs. Hubs, if you think of a bicycle wheel, for instance, you have the hub in the middle, then you have the spokes going out, and outside you have all the clients sitting and talking via the spokes to the hub here in the middle, okay? And this is what a hub is. And in our case, if we do it everything serverlessly, then we use a serverless hub as our base class for implementing our hub here. Now, let's forget about the negotiate endpoint here. We will talk about that in a second. First, let's talk about these two guys here. These two guys are just two demonstration functions where you see how you can receive interesting events from SignalR without implementing SignalR, because Azure SignalR will go to your Azure function, in this case to the serverless hub, and will inform you whenever a client connects or disconnects from your service. You can also actively send messages through SignalR from the client to the server, but this is a story for later on. The real problem is, how can we understand that a certain connection is linked to a certain user? Because in our use case, we don't implement a chat functionality where we always broadcast everything to the entire world. We want to specifically send messages to certain users or even groups. SignalR service allows you to maintain groups of users, so it makes it even simpler to address a list of specific users if you want to do that. In our case, we don't need groups. We just always talk to a specific user. And in order to work that, in order to be able to do that, we have to implement something which is called a negotiate endpoint. What does negotiate mean? The negotiate endpoint is a mechanism of Azure SignalR. Negotiate is called by our client. So the Blazor client will talk the negotiate endpoint using HTTP calls. An HTTP request comes into this negotiate function. And guess what? We can add authentication, a token, a JWT token, just as we did before, to this negotiate endpoint. We can validate the token. Is this the correct user? Yes, it is. And we can extract the user from the token. And then comes the important stuff. Then we go to Azure SignalR and we can say, hey, SignalR, this WebSocket connection, this SignalR connection is, logically speaking, this user. So we can tag the SignalR connection, the outgoing connection, with a specific user. And whenever we send out SignalR messages using Azure SignalR, we just need to tell SignalR this should go to this and that user, and it will look up this user in all the servers where all the WebSocket connection terminate, find the right server where the user is connected, and push the data out to this specific user by using the same JWT token authentication that we are used to for plain good old REST web APIs. Of course, again, my implementation here is rather naive. In real world, the token would come from Azure Active Directory. You will probably use Microsoft's implementation of checking an Azure Active Directory token, but maybe in your case, it's Identity Server or Signal or Auth0 or something like this. It always works the same, and I just did my naive implementation here. Okay? So this negotiate endpoint has to be called by our Blazor client. So let's add a little bit of client code here whenever we log in. Because when the user logs in and we have the JWT token, we can now establish a connection to our SignalR service from the Blazor here. Okay, let's do that. I have written a small helper function that I will copy in. Let's put it here. Here it is. And this helper function is really simple. Negotiate. Okay, I need a very, very simple. Where is it? Negotiate result here, class. This is trivial, just a data transfer object. So forget about this class. It's not that interesting. This method calls, as you can see it here, the negotiate endpoint and presents the bearer token. And what it will get back from the negotiate endpoint is two things. First, it will get a URL, and this URL will point to the Azure provided SignalR endpoint. So what we are telling the system, or what Azure Functions is giving us, it gives us, hey, you have a client that would like to speak SignalR with you. This is the URL of Azure SignalR where the client should connect to. This is if you want your emissary, your German Botschafter, who will do the SignalR protocol, the WebSocket termination, and all this stuff. So this is a kind of redirect. Dear Blazor, talk to this URL if you want to talk SignalR with me. And the second thing that we will get back from this, let me show it here with the hub, from this method here, negotiate, the second thing that we get back is an access token. This is a translated access token that you can present when you connect to the SignalR server. This is not our original access token anymore. This is an access token that the client can use to prove that the client has talked to the to our API, and that the client has correctly presented an Azure Active Directory token and has proven that, in our case, he is John Doe. Then it will repackage a new jar token, give you this jar token, then you can take this jar token and give it to Azure SignalR. And then Azure SignalR understands, aha, first, we allow this client, and second, this client is John Doe. Understand it? I hope so. If it was a little bit fast, you can take a look at the code, or maybe we have a few minutes left after my talk. We still have 15 minutes. We are good in time, so probably it will be possible to answer some questions here. This is where we get the SignalR connection, and now we can use this get SignalR connection during our login process in order to just start a SignalR connection. Go to the login here and add a bunch of lines of code, not complicated code. As you can see it here, we get the SignalR connection. We use the SignalR Hub connection builder. We specify the URL. We specify the access token. In practice, we will probably add some more elaborate code for doing auto reconnect and all this stuff. And then we can say, if we receive something from the server, a message with category order event, then we display the order event here on the screen, and then we start our SignalR connection. Let's add the SignalR Hub connection property here. Let's do that. Good. Sorry, I have to close the shades a little bit because the sun is coming in and I don't see anything. Good. Works like that. Yep. Looks good. And now, as you can see, code should compile correctly. Finally, in the logout method, we have to also do a little bit of SignalR work. Here, where is the logout? Here is the logout message, and that one is it, and that will close the hub connection finally. For those of you who are not familiar with SignalR, this stuff here is just plain SignalR. It works in the browser, in Blazor. Isn't that beautiful? We can take a .NET assembly from NuGet. This is the same SignalR client NuGet connection that you have maybe worked in WPF or WinForms or anything anywhere else, but now we use it in the browser from C#. I really think that Blazor has gone pretty far so far, so it works really nicely. That gives us a connection to Azure SignalR. Very nice. Now we have an established connection, but not directly with our serverless function. but we are talking to a serverless service in Azure, and this serverless service understands that the user is John Doe, and whenever something interesting happens, whenever we use an output binding in Azure Functions, which we will see in a second, then it understands where to send the event. So let's add that, and then we can do another piece of debugging. And we are nearly at the end of the example. Good. In our case, we have to change the process order function a little bit. And in order to not make any mistakes here, I will just replace the entire function here and take a look at the code. So yeah, a helper function. I've created a helper function here too. This one. Good. Now let's take a look. The process order now got new, as you can see here, an output binding to SignalR. And this output binding to SignalR is connected to our order processing hub. The order processing hub, if you can remember correctly, was the one with a negotiate. So therefore, things go together. So whenever we add a message to this collector here, the Azure Function Runtime understands that we in reality want to send out through WebSockets, through SignalR, a message to a specific user. Now, how do we send the message? Very, very trivially, using the add async method. Can you remember? We had this one before. It's exactly the same programming model that we had before when we used the service bus. Conceptually, it's really similar. We are sending a message using a message bus, or we are sending a message using SignalR. The technology below is completely different, but it's abstracted from us. And that's the beauty of this technology here. We just add something async, and as you can see, whenever the progress, here you see it, changes, we send out some intermediate steps. We send out, hey, yes, the product is in stock. Okay, we have registered everything in our ERP system. Okay, your credit card was successful, and now we are done. This is what we want. This is the experience that we want to have. And how do we filter for a specific user? Well, very simple. We take the user ID, which we have in the order, which came from the jar token. We put it here inside our SignalR message, and that is all we have to do in order to route everything from our Azure function to the SignalR server to the client. Okay? Good. I have no idea if I messed something up, so let's take a look. Okay, it's built. Let's give it a try. Good. Here we have it. Okay, with no red squiggles here, so that looks good. Login as John Doe works. And now let's do it. Let's remove the breakpoints here in order to see it a little bit better. Okay, I will log out again, log in again, and now send the order. You see, sending order, order sent, successful availability check, successful sent order, and finally the credit card processing was also done. This is exactly what I wanted to do. Okay, I currently have no idea where the others came from, so no idea. Let me check again. So again, now it looks good. Order sent, successfully availability. Maybe somebody of you is trying on your own and you copied my code and you just copied something. Maybe you played a little bit, or it was old stuff in the service bus message queues, could be. But this is how it should look like. So log in as John Doe, send the order, and you see now we get, using SignalR, the messages. And I can prove that this is real WebSockets by taking a look at the networking stuff here. Let's show all the logs here, log out again, log in again, and send the order. Now here you see this is the SignalR connection, and we can take a look at the messages. Let's send another order. You see, we send the order, and now we have coming back the messages from the serverless function, and we get all the status messaging just as expected. And the messages are sent back to the correct browser client, exactly as we expected them. If we, for instance, take this URL and go here, and this time we will log in as Jane Smith. Let's do the following. Let's log out here again and log in as John Doe. We send here something, and you see Jane Smith is not bothered. So the routing works based on our JOT authentication stuff. And if we send an order, this is fine too. John Doe is not bothered with the messages from Jane Smith. So our sample really works. We now have a serverless function talking to our browser client written in Blazor using SignalR without us having to implement SignalR and being completely serverless. Finally, for the last very small demo, I would also like you, for the sake of completeness, I would also like to show you another piece of demo that I prepared. It's, I think, interesting to understand how this stuff works. You will probably rarely use it, but it is really useful for understanding the whole protocol flow here. I will add another button which says say hello to server async. And I've implemented this method. It is the most complicated method that we are going to write today. It consists of a single line of code, of course. As you can see it here, it just says hub connection send async. So what this stuff does, it sends a message via WebSocket, not via REST API, through Azure SignalR to our serverless function. Now, where in our serverless function can we find the say hello async method? We can find it in the order processing hub. Before I didn't mention it, but here you can see, here you can see this function say hello async, and it is a regular Azure function, a serverless function, but in this case it's triggered by SignalR. And those of you who are watching this talk very closely, and those of you who are familiar with WebSockets and SignalR might now ask themselves, how can that work? The client, this is not a good thing, so let's do this one. Yep. The client, the Blazor client, has no direct connection to the Azure function. In fact, the Azure function could be completely removed from memory. There is no Azure connection, Azure function. At one point, if it is idle for a longer time, it's completely removed. The thing that is still sitting there and waiting for messages is the Azure SignalR service. It's terminating the WebSocket connection and it's waiting for messages. And if now somebody sends a WebSocket connection, a WebSocket message doing an RPC to say hello, the Azure SignalR stuff has to somehow wake up our Azure function and deliver and issue this SignalR trigger. How can that work? What is the underlying protocol? How can that really work? I can show you that it really works. Let's run it here. Here on the left-hand side, you see the server. I will log in as John Doe, and please watch here on the left-hand side, the message is going in, say hello, and you see here, got message from client hello. So this was the proof. It really works. How can Azure SignalR send a notification using, you can see it here, it's kind of cheating here, an HTTP request to my local development machine, which I can assure you is protected by firewalls, so it's not sitting out there in the wild? The answer is here. The answer is here. I'm currently using ngrok to publish my function, as you can see it here, via an ngrok tunnel. So for development purposes, I'm punching a hole into my firewall and I'm allowing everybody to access my localhost using this URL. I can now imagine that everybody is now immediately typing in this URL and trying to hack my machine. It will not work because I now terminated it. Okay, but why? How does that work in real life? Well, the answer is exactly, where can I find it? Where can I find it? Here. Azure SignalR This is the service that terminates our WebSocket connections, understands the concept of an upstream event handler. And this upstream event handler is nothing else than a webhook. So what I essentially did is I set the upstream event handler to my ngrok URL. And so technically, the communication between Azure SignalR and our Azure function is working via a webhook, but I don't need to write the webhook. This is done by Azure Functions. This is provided by Azure Functions. And if you want to have this receiving of events, incoming messages from the client, connected event, disconnected event, you have to set the upstream URL accordingly. In development, you will probably use a public IP, a public DNS name, or something like ngrok or any other ad hoc VPN tunnel into the cloud. At real time, when this stuff is really running, when this stuff is really executing, you will, I added it here, you will use a URL something like this. So as you can see, azurewebsites.net, and this stuff here, including the API key, this is provided by functions, and you just have to tell SignalR that you want SignalR to provide messages to this endpoint. And now everything is done. Everything is done. Our example is really working. So our example is working because here the client does an HTTP request to our Azure function. Then we have backend processing using service bus queues. And we have, let's go here, Azure SignalR sitting in front of our Azure function and doing the connection between the browser and the SignalR service. We only have this negotiate endpoint where the browser goes to our Azure function and say, I want to talk SignalR with you. Where can I find your SignalR endpoint? And it will give back the public SignalR endpoint from Azure, and therefore we don't have to think about anything regarding WebSockets. Okay, that was it. I'm really glad that everything worked as expected. I was a little bit nervous because it was a lot of live coding and a lot of copying together, but I hope you enjoyed this sample, and I hope it gave you a clearer idea what you can do with Azure Functions, serverless programming, and SignalR. And the use case had a little bit of a real world use case, a little bit of real world relevancy to you. With that, I am more than happy to take any questions. Raul, are you there? Do we have any questions from your side or from the audience?
Can you hear me, everybody?
I can hear you loud and clear.
One very long question.
Oh,
try to understand it.
Shoot.
Now, so Fabian asked, did I understand this correctly? The serverless hub class is really deployed as an Azure function, but wired into the Azure Signal service as a webhook. Is this
correct?
So
correct.
Part is the serverless hub base class part of the Azure SDK, or did you create it yourself?
No, I did not create it myself. It's part of the, let's stop here and go here in the Blazor server. This is the Azure serverless function. And as you can see, just as you have a NuGet package for service bus trigger and output binding and input binding, exactly the same, you have the SignalR service extension NuGet package. Just add this SignalR service NuGet package to your Azure function, and you have this base class automatically. You don't need to implement it on your own.
Okay. So next question. I don't know if the stream hears me, but Rainer hears me.
I hear you.
Next question. How does the negation method really work?
How does the negotiate method really work? Well, if you want to know it exactly, I can show you. Let me quickly open up a browser. So don't be angry with me. You asked, remember, so if you ask me, I will answer, okay? So let me quickly take a look in my own repository. And it so happens that I implemented the negotiate methods. Do I have it here? Let me quickly see whether I can find it quickly. I've implemented that. It's not here. Give me just a few more seconds whether I can find it. Otherwise, I will tell you if I can't find it immediately. I have so many examples. Yes, here it is. I finally found it. So this is an example I did. You can find it here. It's recorded, so you can take a look. And here I implemented the negotiate method in a language that is not officially supported, that has no SDK. So I essentially implemented the negotiate endpoint by hand. And what you have to do is you have to create your own JWT token where you add a specific audience. This audience is well defined. It's part of the documentation. So you know what the correct audience is. You have to sign this token with a specific key, which is also defined. It's essentially, yeah, you can take a look at the documentation. And then you just build the negotiate result by providing the negotiate URL, which is just the URL of your SignalR service, which you can find in the Azure portal. And the access token is the JWT token that you can build by hand. So what the negotiate function in C# essentially does, it calls this method of the base class of the serverless hub class. And this negotiate function does nothing else than with a specific set of parameters creating a JWT token and baking in all the user stuff. And you can also add some additional claims here. Let me show you that here. You can specify additional security claims here. It will create a JWT token where all these things is baked in. And the exact definition, how you have to create this JWT token, where you can find the public key that you have to use in order to sign all this stuff, this is part of the documentation. You can look it up in the SignalR service documentation of Azure. So nothing special here, just a URL which you can get from the Azure portal or simply look up in the documentation, and building a JWT token. A little bit of JWT magic. All you need is a JWT library, and you can forget about this method at all and build it on your own, as I have proven with the Go example. I hope this answers your question.
Yes, Fabian writes it's exactly what he want to hear and answered it perfect in detail. So did we have any other questions? No. I don't know if...
No other questions?
If not, I think you can ask Rainer every time over the...
Absolutely. Just contact me via Twitter, send me an email, or wherever you want to find me. Let me before I leave, I would like to make a little bit of an advertisement, if you want, announcement. Last month we started with a brand new meetup, which is very important for me. I'm one of the co-founders. We started a Rust meetup in Linz. So if you are interested in Rust, Microsoft is looking more and more into Rust. Rust plays nicely with other Microsoft technologies, and if you want to do system programming, but C++ is not the correct one for you, take a look at our Rust meetup. You will find the next one at September 17th. We will have Megan Lewis as a speaker, as a guest speaker, and Roland Ruckerbauer, a local who is already using Rust for quite a while. This is a new meetup, so we are actively looking for people who are interested. It's especially targeted not only for Rust experts, but also for Rust beginners. So I hope, Raul, you are not angry with me because I do this ad here if you want, but this is really important for me, and therefore I wanted to bring it up.
No.
With that, I say thank you and give back to you, Raul. I say thank you for having me, and I hope
Rainer,
you
we
enjoyed
have
the
two
presentation.
questions. I hope the questions are not as long.
Good. Questions,
So,
shoot.
First is, how does the connection between client and hub done? This,
The connection between client and hub via WebSockets. This is just plain old SignalR WebSocket as you are used to. So if I can start this example again, and I can debug it again. This is just WebSockets. If you are not familiar with WebSockets, just take a look at my slides. This is why I added the additional slides here. For those who are not familiar, network, if I log in, what you will see here in the negotiate endpoint, let me see if I can find it quickly here. Yeah, here we have it. As you can see here, it's essentially an HTTP request. Yeah, an HTTP request where the response is 101 switching protocols. This is how WebSocket works. And if the client says, I would like to talk WebSocket with you, this is the URL, by the way, of the SignalR server that I'm using. If the client says, I would like to talk WebSockets with you, then this server provided by Azure will respond with 101. And from that point on, everything is text or binary, message pack or text. And this will be the protocol between the client, in my case, Blazor, in other cases, Angular or React or whatever, and the server. So this is plain WebSockets. And as you maybe know, SignalR also supports other protocols like long polling or server-side events. So if the network devices between the client and the server don't support WebSockets, it will fall back to other protocols and, let's say, emulate the duplex connection using other protocols. I hope that answers the question.
Yes, perfect, thanks. Other question, why not use SignalR for both ways in communication instead of HTTP?
That's a perfect question, and the answer is it depends. You can absolutely, the only thing that you really need is the negotiate HTTP endpoint. That's the only one that you really need because, as the name suggests, it's necessary for negotiating the whole connection properties. Everything else could be done full WebSockets if you want. Yeah, but if you ask me, I am more the simple guy. Okay, APIs, REST APIs are simpler to use. I have my Postman or my REST client, and I can write an HTTP post in any language. I'm a beginner in Rust, but I still can write an HTTP request in Rust. So building an HTTP-based API for sending in orders enables everybody to trigger the business process. The back channel with SignalR is optional. If you have a client that doesn't support SignalR, well, yeah, you don't have a back channel, but still you can talk to my server. So I personally think that still REST APIs are a great way for triggering business processes. You can do it with SignalR if you want. If you enjoy SignalR, if you work in an environment where SignalR and WebSocket are fine and everybody has it, party on, no problem. This is a question of you deciding your API. And if you decide that web APIs is the way to go, I think it's a good idea. If you decide WebSockets and SignalR is the way to go, party on, it will work nicely. It's up to you. It depends on the use case. Raul, any more questions?
Thank you. No questions currently. Any questions? Last chance.
Last chance.
So, okay, then thank you, Reinhard. Then I will hand over to the last slides from my side. So, thank you a lot, Rainer. And so, thank you. It was a very very interesting talk. I learned a lot. And everybody else, thank you for joining us. And also thank you to our sponsors, T8 to Everywhere and JetBrains. And now, if you want also to become a sponsor, your company become a sponsor, come to us, to me, Andy, if he's back from his paternity leave, and Martin Ulrich, can you also contact if you want to sponsor the .NET Meetup or host the .NET Meetup in any time. Oops, too fast. So when we can back meet us personally, we also searching every time for hosting. So talk with us. Here is the link for sponsoring and hosting. Our next plans is we want to make one meetup in September. We don't have a date now and no topic. So if you want to speak, talk to me or Andy. And in October, we have one topic and a date. We have two topics. It's on October 20. And the topics are clean architecture and the brighter framework. So we have not announced it now in Meetup, but we will it in the next days. And November, we also want to make a Meetup at every time. But Corona, we have everything to do in the cloud. So if you want here some topics, you want here some request topics for future meetups, want here maybe Blazor, we see today Blazor, some parts, or Packet or Noda time, or you have other topic requests. We have a request list in our GitHub repository. You can make a pull request that we find out the meetup, the topic for our meetups, and maybe we find a speaker who can make the topics. Oops, I can work with my mouse. So, and please spread the word. Invite colleagues, invite friends, invite customers, make tweets about .NET Devs Austria. Tell everybody that we exist, that our meetup is in the world, and so that we become bigger. And maybe when Microsoft knows us, we become much more. Some speaker from the States or something sponsoring, so that we can make the meetup better and better. So again, our list of topics and websites. We will upload this talk on YouTube as soon as Andy can render it and cut it. So follow us on Twitter, Twitch, and maybe we can talk in our Slack channel. So, and at last, we want to hear your feedback. Here's the link of our feedback form, and we'll also post it in the chat. And yeah, fill out it. Maybe, I don't know if we have something to win this time. Andy make it, organize it, but we want to learn from you, hear your feedback, what we can make better. Maybe I will get my echo away from the speaker. And so, thank you everybody, and thank you Rainer again. It was a very interesting talk, and see you next time. So, thank you, bye.